On April 20, 2025, a new picture shared by Lex Kataev confirmed that Russian Tu-19 Msta-S self-propelled howitzers are now being equipped with factory-installed counter-drone protection. The picture revealed a metallic shielding structure now covering the turret, intended to shield both the crew and the ammunition loading mechanism in response to increasing losses attributed to Ukrainian FPV drone strikes. The integration of these protections at the factory level indicates a shift in Russian production standards, reflecting lessons learned from extensive battlefield losses in Ukraine. The increasing use of unmanned aerial vehicles by Ukraine has had a significant impact on Russian battlefield losses. In January 2025, drone strikes were responsible for 66% of Russian equipment losses, according to statements by Ukrainian Commander-in-Chief Alexander Syrsky, representing a 7% increase compared to December 2024. FPV drones accounted for 49% of all equipment losses. Ukrainian units, including the 46th Airmobile Brigade, 3rd Assault Brigade, and 80th Air Assault Brigade, have made extensive use of drones for both reconnaissance and strike missions. Russia, in turn, is formalizing its own drone warfare capabilities, planning to recruit over 210,000 personnel into unmanned systems roles by 2030. This includes the formation of 277 specialized units and the development of naval drones with AI-driven functionalities. The presence of these drones has contributed to the loss of a significant number of Russian self-propelled howitzers in Ukraine. As of April 22, 2025, a total of 916 Russian self-propelled artillery systems have been visually confirmed lost. This includes 751 destroyed, 49 damaged, 7 abandoned, and 109 captured units. Among these, Russian forces had lost at least 234 Tu-19 Msta-S and 52 Tu-33 Msta-S M2 units. Of these, 171 Msta-S howitzers were confirmed destroyed through photographic evidence. The remainder were reported as damaged, abandoned, or captured. These losses also highlight the Russian need for additional protective measures beyond ad hoc field modifications, which have proven insufficient in high-threat zones. The development of the Tu-19 began in the late 1970s as part of the Soviet USPYE KH-2 research program, aimed at countering NATO artillery developments such as the FH-70 and SP-70. This led to the design of a next-generation self-propelled howitzer designated Object 316, later officially adopted as the Tu-19. The vehicle was developed by Ural Transmash in cooperation with the Barakati Design Bureau, incorporating lessons from previous Soviet artillery systems, focusing on automation, firepower, and tactical mobility. The Tu-19 entered service in 1989 as a replacement for the Tu-3 Akatsiya and was first shown publicly in August 1992 at the Zhukovsky Air Show. Since its introduction, the Msta-S has been developed into several key variants to meet evolving battlefield requirements. One of the most significant upgrades is the Tu-33 Msta-S M2, which features a modernized fire control system, improved navigation, and a higher rate of fire, up to 10 rounds per minute. Some configurations include thermal signature reduction and integration with advanced command and control networks. Another export-focused variant, the Tu-19M1155, was adapted to fire NATO standard 155 mm ammunition, expanding its appeal to international markets. Other experimental versions included the wheeled Tu-21 Msta-K and a dual-barrel variant developed under the Koalitsiya program. Neither entered service. Despite these updates, The Msta-S family faces limitations in maximum range and automation compared to more modern Western systems like Germany's PS 2000 or China's PLZ-05. Both capable of engaging targets at greater distances with more advanced shell types. The Msta-S is built on a chassis derived from the T-80 main battle tank, later modified to the T-72 platform for cost efficiency and ease of maintenance. It is powered by a V84A diesel engine producing 840 horsepower, giving it a maximum road speed of approximately 60 km per hour and a range of up to 500 km. The vehicle is armored with 15 mm steel plating sufficient to resist small arms fire and artillery fragments. It includes a turret-mounted 152 mm howitzer, automated loading systems, and NBC, nuclear, biological, chemical protection for enhanced survivability. The standard crew comprises 5 members: commander, gunner, driver, and 2 loaders. Internal ergonomics are designed for long-duration operations under adverse conditions, and its communication suite enables integration into broader battlefield networks. The Msta-S is armed with the 152 mm 2A64 howitzer, compatible with a broad array of munitions, including high explosive fragmentation, HE-frag, shells, cluster munitions, and laser-guided rounds. Standard HE-frag shells can reach up to 24.7 kilometers, while rocket-assisted projectiles extend this to around 29 kilometers. The Krasnopol laser-guided round enables high-precision strikes within a 20-kilometer range when paired with appropriate target designation systems. The system can also deliver cluster munitions for area denial, as well as experimental rounds under development aimed at extending its reach beyond 30 kilometers. Some munitions may have alternative payloads, including electronic countermeasures or specialized warheads. The system carries up to 50 rounds, and the loading system includes automatic ramming. A 12.7 mm NSVT heavy machine gun is mounted on the turret for local defense. These munitions allow the Msta-S to conduct both saturation fire missions and targeted strikes, adapting to shifting tactical needs on the battlefield. The Msta-S has seen operational use in numerous conflicts involving the Russian armed forces. During the First and Second Chechen Wars, it was deployed for long-range bombardment of fortified positions and urban targets. It played a similar role during the 2008 conflict with Georgia, where it provided fire support to advancing ground units. In the ongoing war in Ukraine, both Russian and Ukrainian forces have deployed the Msta-S, with Ukraine capturing and redeploying several units. Ethiopia is also known to have used the Msta-S during its border war with Eritrea, taking advantage of its range and indirect fire capabilities, which enabled surprise attacks perceived as air raids due to the absence of launch noise at the impact site. Within the Russian ground forces, the Tu-19 Msta-S remains a principal component of divisional and corps-level artillery units. It is tasked with delivering suppressive fire, executing counter-battery missions, and providing direct support to maneuver brigades. In Russian service, the Tu-19 is organized within artillery regiments and separate artillery battalions of tank and motor rifle brigades. Each battery can include up to 8 howitzers, supported by command and observation vehicles. As of 2024, Russia fields approximately 300 Msta-S, Msta-S M1 units and 300 Msta-S M2 units in active service, with an additional 150 Msta-S howitzers in reserve. The system remains a core component of Russian artillery, although it is gradually being replaced by the Tu-S35 Koalitsiya SV, which features extended range and fully automated loading.